Now we can start working on our project. So first thing, we have to create a folder, and let's call this liquidity. And this is the folder we have to open in our VS Code. So click on your code editor. And in this project, I'm using VS Code. You can use any, but I would suggest you to use this one because it has a lot of powerful extension which we can use it. Click on this open and go to the desktop and select the folder. So click and select. So once we have our folder ready, now we can start getting the strata file. So come back to the blockchain coder, and here you will find all the resources which you need to get for becoming a blockchain developer and building this project. So simply scroll all the way down and check all the project we have here. Now I have recently launched this particular course, so you can simply check that. Here you will find everything which you have to know, like to master blockchain development, like Solidity, programming language, multiple smart contract, and we're going to build one of the biggest project. You will have a couple of crash courses as well. So make sure to come and check this one. Now let's get the starter file. So click here, go to the source code, and here you will find all the project we have built on our channel. So simply scroll down and check all the project. We have more than 30 project, and this is the one we're going to build it. So you can simply come here, you can simply filter by recent, or you can simply type the name. So click on this get now, and here you will have this final code and the startup file. So you can get that, or you can get the startup file. So click on the startup file, and here we are on GitHub, and here you will find all the startup file which you need to build this particular project. So simply copy this, and now copy this URL, come back to the code editor, and now we have to simply clone this repository. So simply type get clone, paste the URL, and give this dot. So it's going to clone the repository in the same directory. If you don't provide this dot, it's going to create a separate folder. So provide and hit. It will take few seconds, and finally we have cloned the entire repository. Now let me give you a quick walkthrough that what exactly you will have into the starter file. So let me zoom a bit. Let's expand this one. The very first thing you have to do is you have to simply delete this one. Delete this one. Now open this component folder. Inside that you will have the CSV folder. Inside that you will have the icon, and we have a rest of the components. So if I open this one, this is the two icon we have for the footer, and then we have the access, add liquidity, pool, all these components we have here. And we're going to simply import all of the component to in this index file, and from here we're going to export it, which I have already done in the startup file, so you don't need to do anything in here. And we have the list of the component. So far things are good. Now close this one. Now let's come back to the context, and here you will find some important resources which we need to work around this crypto exchange. So we have the API. We have two different type of API, one for the ERC20 token, and the one is for the factory contract which we are utilizing. So this is the factoring contract, and this is the contract which we're going to build together. So I have given you this API in advance, but you can simply delete it or you can keep it. But I would suggest you to let it be like this, because later when we'll deploy the contract, we'll generate a new API, and that's what we're going to simply replace with. So this is fine. We have all the API, and we have this constant. In that we're going to do some setup for our addresses and the APIs, and here we're going to build the entire context management, and that's what we're going to simply export from here. So this is the context we have. Now we have the contract, and inside the contract we have these three files. We have ICO contract, liquidity contract, and our token ERC20 token contract, which we're going to code together. Now we have to say the page, it's going to be a single page application, but here you can see in the app.js I've already done all the configuration for adding the JavaScript, because we are using some sort of animation as you have seen in the demo. So we are using all of these animations libraries which has different utility models. That's what we are utilizing here. So you have to let it be like this. All these files are coming from the public folder. So inside the public you will have the CSS, font, images, and JavaScript folder. So we are getting all of this from JavaScript and JavaScript plugin. You can see it's had the huge files. You don't need to do anything in here. So close this one. Now if you see this CSS file, this is what we're going to import in our global CSS, and we have the font, and here we have the images which we're going to utilize it. So we have all of these different images which you can do the experiment, but I would suggest you to simply follow the project the way I'm building it. Now close this one, close this one, now close this one, and here we have the page, index page, and it's going to be a single page application. So all the component we're going to simply import here, and context function we're going to import here. Now close this one. Now come back to the script. So here we have the deploy script which we're going to create together for deploying this particular contract. So here we have this style, and we have the global CSS. So I have already done the import. So this is the CSS files we have, and I have already written some custom CSS which you will find here. You don't need to do anything in here. Once you complete the project, you can do the modification in the color and the styling, but just build as it is. Now we have the test, which you don't need to worry about it. Here we have the utils folder. In that we're going to write the utility function, which we're going to use it like for handling error and for managing the addresses. So that's what we have here. And this is what we have. And here we have done this particular configuration. So close this one, and here we have this NextJs config file. Don't need to do anything in here. And here we have this package.json file, and you have to pay a little attention here, because whatever script we're going to utilize it here, whatever packages we're going to utilize is here, it's 100% compatible the package version we are using here. So this is our script for development, and here we have the dependency. These dependencies are very important. You have to use the exact one, the one I'm using right here. So this is the hardened version we are using. Make sure you have to use the exact one, and everything looks fine. Don't need to do any changes here once you download the starter file. So we have these packages. Now all we have to do is to simply install this one. So come back here in the readme file. Here I have provided some important links which you can simply check. So close this one. Now we have seen the folder and file structure for our project. Now it's time to install the packages. So simply open up your terminal and simply clear your terminal. Now before you install the packages, you have to check your node version. So this particular hardened package is 100% compatible with this particular node. So if I open this node, so right now we have this 20. So those of you who will have latest version of node like 19, 20, this hardened is not compatible with this particular node version. Maybe in future they're going to update the hardened package and it will be compatible with this particular node version, but right now it's not compatible. You can easily come back here in the hardened installation, and here you will find the entire information that why it's not compatible, when it's going to be compatible. So make sure to come and have a look. So it is compatible with this particular version. So you have to install the exact node version which I am using, because Hardhat is compatible with this particular node version. If you will have the higher node version, it's going to unzip the entire package and it will install individually one by one. In that way, this particular Hardhat will not going to work in the project. So we need as a global installation which is compatible in this particular version. So simply type, we can type node dash v. So make sure you have to have this particular node version v18.12.1. If you have the higher version, make sure to downgrade it to this particular version, which you can do it very easily. And if you have the lower version, make sure to upgrade it to this particular version. Now you have to also check your npm version. So I'm using this particular one. So these are the two must installation version you have to do in your computer before you start working on this project, which is very easy. All you have to do is to simply downgrade your node version to this particular one. And in case of you don't want to use Hardhat and you want to do all this deployment of the contract and testing on the test network, then you can easily skip this Hardhat. For that, what you have to do is make sure to keep this particular folder contract, and inside that make sure to have these three contract files and write down all the contract which we're going to write it together in this particular project. Keep it there. The only thing you have to do is you have to remove a couple of folders. You have to remove the script folder because we will not use the Hardhat, and you have to remove the Hardhat config file, and you have to also remove the Hardhat packages from the package.json file. Simply remove that if you don't want to use Hardhat in the project and want to do the deployment of the contract to the test network. Now come back here and let's try to install the packages. You can see I'm getting this particular warning. The reason why I'm not upgrading, because I have couple of project which is going on and I have to do the testing, and I'm using this unit test using the Hardhat. That's why I'm keeping it. But after a few days, once I will complete the project, definitely I'm going to upgrade to my latest version and it will not cause any issue. So simply remove that. We have done the successful installation. Now let's start the application. Type npm run dev, and here our application got started on localhost 3000. So simply copy this one and let's come back here, open a new tab, close this one, open a new tab and paste here. So our application is working absolutely fine. We have done the entire setup properly, and here we have this index text. Now looks good. Now come back here, stop the application from running, and let's clear it out, close this one. Now what we're going to do is let's build out all the important functionality for our application, functionality for our application. So let's start with that. So first thing, what I'm going to do is I'm going to start with the utility model functionality. So come back to utilities, and here we have to write the two important function which allow us to sort the address, and whenever any error take place in the contract, we have to capture that and we have to display in the front end as a meaningful message. So let's build this to functionality, which is very simple. We can do it very easily. So close this one. We have to say export const short address. In that, we're going to receive the address, and all we have to do is to take this template literal. We'll take this short address dot slice, and I want to simply short down the first 6 character. Then I want to take the last 4 character of the address. So it will give the first 6, then it will give 3 dot, then it will give the last 4 character of the address. So this is the very first function we have. Now let's build the second function for throwing error. So we'll say export const parsed error message. It's going to take the entire error object, and once we have the entire object of the error, we have to simply take a variable called JSON. We'll say JSON parse, and that we have this particular data called JSON.stringify, and in that we can simply parse the error object. So it will give the JSON information, and now we have to simply return that. So we'll take this JSON, and we have to give this question mark, because sometime what will happen that it will return undefined. So we have to catch that as well. So if we don't give this question mark, it's going to throw an error that there is no data available, and sometimes it takes a little bit time to get the data. So always make sure that you have to provide this question mark, so it will put a condition and it will not throw an error if the data is not available there. And we'll say reason, else we can go with the error dot message. Got it? If we don't have the message, then we'll display the reason that why the transaction failed. But if we have the message, then we'll display the error message. So this is the two function we have to write for our utility model. Hope things are clear to all of you guys. Now click here. Once we have here, come back, close this one. And now what we're going to do is let's write down the contract. So we have 3 contracts, and these 3 contracts are pretty huge. So let's write down that. So open this one. And the very first thing we're going to do is we're going to write our token contract. We're going to write our token contract. And you have 2 options to write this token contract. You can use OpenZipLin library for writing the contract for ERC20 token, or you can build your own custom. But I want to show you everything from scratch, that how you can build your own custom token with more functionality. That's why I'm just going to write the custom token contract instead of using the library. So here, let's open this one. Now we have to simply write the license identifier. So we're going to use this MIT. Now we have to take the Pragma Solidity version, and this time we're going to use 8.0. Now let's call our contract to be Woox, and let's define a couple of state variables. So first thing is going to be our name of the token. You can go with the hard code, or you can simply define the name of the token at the time of deployment, but I'm going to go with the hard code. So we have the name, we're going to have the public symbol, then we're going to have the standard. So this is the additional variable I'm adding, because in case in future I have a different standard of token which will have some other feature, so that's why I'm giving this version 1 number. Then we have this UNT variable is the total supply, which I'm going to define at the time of deployment. Then we'll have the address of the contract owner, and we're going to have this public user ID, because when the user will buy, we have to keep the track of that particular user and assign a particular ID to that. Then we can come back here and let's take the address. In that, we're going to keep all the user who will take our token and keep their addresses in this particular array. Now we can come back here. Let's take the event. So we're going to take this transfer event. In that, we're going to take the address from address to, and we're going to take the value. This is the first event we have. Now we can come back here. Let's take the second event for approval. And in that, we can simply take this address index owner. Then we'll take this address index spender and the amount into UNT value, and close this one. So this is the 2 events we have. Now we can come back here. Let's build the mapping. So we have to map with address to a token holder information. So this is the struct we're going to create it. So I'll call it public because I want to get this information in the front end. So all I have to do is to pass the address of the user, and it will give the entire information about that particular user, that how many token he holds, all of the things. So it will be called as token holder infos. infos. So this is the name I have given. Now we can come back here and I will take a struct. Let's build this one, token holder info. In that we're going to keep a couple of information about the user. So we need the token ID, then we need the address from, then we need the address to, then we need the UNT total token, like how many token a particular user have, because the user can buy as many token as you want in multiple transactions. So that's all we're going to store it here. Then we're going to take the boolean token holder, and that these are the information we are keeping about the user. Now we can come back here. Let's take another mapping, and this time we're going to map based on the ID. So we'll pass an address and going to return a UNT variable. So we'll take this public balance off. Now we're going to map another. We'll say mapping, and it's going to be a nested mapping, and it's going to return called allowance. And you can see I'm getting this particular comment because I'm using this particular extension in my VS Code, and that's why it's giving me this suggestion where I can create the documentation. But in your case you won't have this one, so don't be panicked that what extra I'm getting. Just simply write the contract. Now we have this constructor, and in that we have to initialize the supply of the token. So I'll call initial supply, and first thing I have to define the owner. So we'll say contract equal to message.sender. Then I have to take the balance and I have to assign this balance to the contract owner. We'll say initial supply, and then I have to set the total to be initial supply. This is simple. What we are doing here, we are taking the total supply of the token, and then we are simply assigning the signer as a contract owner. Then we are setting the token supply as an owner to the address, the deployer of the contract, and we are setting the total supply variable. This is the constructor we have. Now we can come back here. Now we're going to build the very first function called increment. I call it in because this will generate a new ID. When you are using Open Zeppelin library, you don't need to create this library, because you don't need to use this function, because you will find a library which you can simply import and it will generate a new token. But we want to build everything from scratch. It's going to be an internal function, and all it's going to do is it's going to increment the user ID plus plus. Once we have that, now we can come back here. Now we'll build the next function. Let's call this transfer. It's going to take the address to and the value. Now once we have that one, let's build this public return. It's going to return the boolean and success. So when the transfer will happen, it will return either succeed or failure, means true and false. Now we can take this requirement and check for a condition, means balance of the user who is calling this particular function has to be greater than the amount of money you want to transfer. Hope you guys have understood that what we are doing here. We are checking the balance of the user who tries to transfer the fund, and the amount he has put for transferring, it has to be greater than that. If it's not, then we have to throw the error message or cancel the transaction. If the amount is greater in the balance, then we have to simply call this increment function, and it's going to create an ID. Now we can simply take the balance of the user and we have to subtract from his account, and we have to simply update it to the sender address, means 2. That's how we are doing the transfer. Now we can take this token holder information and we have to simply update that information. So we'll take this token holder info, token holder 2. Once we update that, now we can take this token holder info and we have to update all of things. So 2 is going to be 2. This is token holder from message.sender. Then we have the token holder info total token. Then we have the total information token holder to true. And then we have this token ID to user ID. So we are simply updating all this information in our struct. Looks good. Now we can come back here and we have to simply push this particular user in an array. And we have to initialize our transfer event, sender, to, and value, and close our function. Return the true, and we have to simply close this one. Hope you guys have understood what we are doing. First we are checking for a condition, then we are doing the transfer, then we are changing the state in our struct, and then we are emitting the event, and that's the only thing. So this is the first, second. So this is the second function, transfer. Now let's write the next function, call function approve, and we'll say address spender amount is going to be the value which user wants to approve to other user to transfer on behalf of him. So this is the very normal function which you have to attach if you are building a ERC20 token. So you can check their documentation that what are the required function you need to have in your token. So this is the approve. Now it's going to be a public. We'll have the return, and it's going to return the boolean success or false. Then what we're going to do is, first we're going to take this allowance and we have to check that message.sender and spender. So we have to build that relation. It's going to be the value. Means the message.sender who's calling this function, he's allowing the spender to spend this much fund. So that's what we have built. Now we have to simply initialize this approve statement. We are allowing message.sender, spender, and volume. Value. And we have to simply return true. So this is a very simple function. It's not science rocket. We are taking the address of the spender and the volume of money, the token he wants to send on behalf of us, and that's what we are simply building here in this allowance. So this is our approve function. Now we can simply go to the next function. Let's call this transfer from. This is also a very mandatory function which you have to follow in ERC20 token development. So we're going to take this address from, then we're going to take this address to, and we have to take the value. These are the information we are getting. Then we have to make it public, return, and we're going to return success or failure. In that, we have to take this required statement and we have to check for a condition. So we'll say value should be less or equal to the balance of the user. Means the one who tried to approve or transfer from, we have to check his balance. And his balance should be less than the amount he tried to send. That's the condition we have to check. If it's not that, then we have to simply cancel the transaction and throw an error. That's the first required statement we have. Now we have to check the another one. We'll say value less or equal to allowance from and message.sender. And this is the second required statement. In that we are checking the value to the allowance which you try to give to the signer, message.sender. So this is the two requirement we have. Now we can simply come back here. We'll take the balance of the user who's trying to call it, and we have to subtract his fund. And all we have to do is to simply update to the 2 in his account. Once we're done with that, now we can take this allowance and simply deduct this message.sender to his volume, because when the user will allow someone else to transfer the fund on behalf of him, so he has given a couple of amount to them, so we have to subtract it from that amount as well which he allowed. So if I allowed account B to transfer 50 token on behalf of me, so whenever the 50 token transfer take place, I have to deduct that 50 transfer. We have to simply initialize the event transfer from to and value, and at the end we have to simply return a true. And that's our transfer from function. So far pretty easy, not that complicated. All we are doing simply checking for a condition, then updating the balance and simply changing the state of the token. Now we can come back here. Let's build the next function called get token holder data. All we have to do is to simply get the address of the holder, and it's going to return the entire information about that particular user, that how much fund he has, what is the token ID, everything and all. So we'll take this public view return, and it's going to return a lot of data. So we have to return unt, then we have to return address, we have to return address from to, this will be unt, this will be boolean, and these are the 5 information we are taking. Now we have to simply return that. So we're going to simply use the mapping. So we'll take this return, we'll take this token holder, in that we can simply pass the address and we'll call it token ID. And this is exactly the same thing we have to do for other data as well. This one is to, and this one is going to be from, and this one is going to be the supply, the token value, total token, and it's going to be the holder or not, so it will return the boolean value token holder. And these are the information we are simply returning from this particular function. Pretty simple. Not that complicated. Now let's come back here. Let's move to the next function. We'll call it get token holder, and this will return all the token holders. So we'll take this public view return, and it's going to return an address array because we already have taken this array, and we're going to return the entire users. So we can come back here. We'll take this return holder token, and that's the only thing we have to do. And this is the entire contract we have. You can see we have taken this state variable for our token. This is the Solidity version, license identifier. This is the state variable of our token, initial stage. In this, we are keeping the address of all the holders. This is the event, approve transfer. This is the mapping for token holder info. This is the struct. In that, we are keeping the ID from to total token and token holder state. We have this two mapping, one for allowance, one for balance of. We have the constructor, which will initialize our contract. Here we have the increment function, and this is the transfer function we have. So we are taking this information, checking for a condition, updating the balance and updating the struct, and at the end we are simply returning the true. Simple. So simply close this one, and looks good. Now let's close this one as well. So this is the one, close this one as well. So this is the transfer, this is the approve. Very simple. Getting this, close this one, close this one, and here we have this transfer from, close this, and this is the changes, close this one, and here we have this get token holders, and simply running all of the data, close this and close this one, and here we have this get token holder information. So this is the entire smart contract we have written for our token, and that's what we're going to utilize it in our ICO token ICO sales contract. So click here. Now we have to go and write this particular contract, ICO Woox. So this is the next contract we're going to write it. So come back here. First we have to import the license identifier. Then we have to take the Pragma Solidity version. We have to import our token contract, which is coming from the same directory. Now we have to build the contract. So let's call this ICO Woox. Then we have to refer the address. So we'll say admin. Then we have to take the token contract. So we'll say Woox public token contract, and this is what we're going to initialize at the time of deployment of this particular contract. In that we have to simply pass the address of the token. This is what we have. Now we can take this UNT 256 public, which is going to keep the price of the token, which we have to initialize at the time of deployment of the contract. Now we can take this UNT variable, we'll call it token sold. That this will keep the count of how many tokens got sold so far, because we have to transfer the tokens to our token sale contract, which is going to have the details that how much token is available in the token sale contract for sale, and whenever any sale will take place, we have to simply update into our token sold UNT variable. Now we can come back here. Let's take an event. We'll say sell. We'll take the buyer. It's going to take the amount. Then we're going to come here. We'll take the constructor, and in that we have to simply take the address of the token contract. Let's say token contract, but then we have to take the price as well, token price. So once we have that, we have to simply update the admin address message.sender. Then we have to update the token contract to be token contract, and we have to update the price of the token. So we'll take price, token price to be token price. So this is the constructor we have. Now we can come back here. Now we have to write our very first function. So let's call this multiply. In that we're going to take two number, x and y. It's going to be internal function. We'll say pure return. It's going to return the third variable, which is a c. I hope you guys are following the interview questions and playlist in which we have talked about this extensively, that what role it's play and what kind of question you will be asked when you will start giving the interview. So make sure to check that playlist as well. So it's going to run the c variable. I call it z, but you can call it c as well. So all we have to do is, in that we have to check for a condition that y is equal to 0 or z equal to x and y, and we have to divide it by y equal to x. Simple. So this is the multiply function we have. Now we can come back here. Let's write the next function called buy token. In that we have to take a UNT variable, so number of token which user wants to take. It will be public payable because there is a fund transfer. Now we have to check for the required condition that message.value should be equal to multiplier, and in that we have to simply pass the number of token which user wants to purchase and the price. It's going to give us the calculation which we can simply compare here. That's what we have here. Now we can come back, we check the next condition, that contract token contract dot balance. So now the second check we are doing, that we are checking for the contract balance. The token sell contract balance should be greater or equal to be the number of token which user wants to purchase. So this one is little tricky. It's not tricky, it's very simple. In the first condition check, we are checking for the price, the number of token user wants to buy it and the price is paying. And then in the second statement, we are checking for the token ICO token balance to the number of token which user wants to purchase. These are the two checks we have. Now we can come back here. Let's do the third check, token contract transfer. And we have to simply call this method.sender and the number of token he wants to purchase, because we have to convert it into a ether. So we have to say 1 and we have to provide 18.0. Hope you guys have understood that what exactly we have done. We are simply doing the transfer using the function called transfer, which we have inside the token contract, and we are passing the address and the number of token, and we are simply multiplying with the 1 and 18.0. Once the transaction take place, we have to simply update our token sold to the number of token got sold, and we have to simply initialize our sell event, message.sender number of token, and close this function. So this one is pretty easy function. We are doing a couple of check and transfer of the fund, updating our token sold state and initializing the event. Now we can come back here. Let's write the next function called function end sell. This function is very important. Like in the previous contract, you will find that this function was not there, but in recent time what happening in most of the ICO contract having this particular function, because sometimes what happened that some kind of bugs you will have in your token contract or maybe token ICO contract. So you can end that particular contract and prevent the user for buying the token. So that's why it's a very important function which you have to keep in mind whenever you are building any kind of function which is going to reset everything. So we'll call this end sale. It's going to be a public, and here we have to simply call this requirement. So we'll say message.sender is going to be the admin, because he is the only one who can call this function. And here we're going to make the second check. We'll take this token contract dot transfer, and we have to simply transfer the fund to the admin address. So admin, and we'll transfer the entire fund which is available in the token contract. We'll say address this, close this one, close this one. Then we have to simply call this payable admin transfer balance, and that's going to make the transfer. And that's the only thing we have to do here in this particular contract. Pretty simple, pretty straightforward. We have the basic functionality which allows us to do this transaction. So first thing we have taken this slide is sent identifier Solidity version. Then here we have imported our token contract. We have, if I come back here, you can see this is the token contract we have built, and that's what we are importing here. And here we have the state variable which keep the admin address, token contract, price, and token sold. We have the event, we have the constructor. We are simply updating the information in our state variable. We are taking the token contract address and the price. Then we have this multiplier function which is going to track the pricing of the token. Then we have this buy function. We have this 18. You can simply calculate it, or you can simply use any kind of converter. So that's what we have here. Now we are simply updating. Then we have this end sell, which is pretty simple function. So we are done with this ICO Woox contract as well. Looks fine, no issue we have. Looks good. Now come back here, and now we have to write the liquidity contract, which is going to keep the track of all the liquidity which user will click using our platform. And so this is what we're going to build now. So we'll take a license identifier. Then we have to take the Solidity Pragma version is going to be 8.10. And now we're not going to import anything in here. Let's call this contract and call this liquidity. In that, we have to take the address public admin, the one who will deploy the contract. Then we have to take the mapping, and we have to map the struct. So we'll say liquidity information. It's going to be an array type. We'll say public liquidities. Okay, make sure to give the exact name the way I'm giving. So liquidities. Once we have the mapping, now we can come back here. Let's take a UNT variable called liquidity ID. So by liquidity ID, and it's going to start with 0, 1, 2, 3 after every token will create, this number will go up. Then we can take a struct called liquidity information. In that, we're going to take all the information from the user. So we want to take the ID, then we'll take the address, the one who's doing the transaction, then we'll take the token A and the token B, because the user can create liquidity in two different tokens in the pair. Then we have to take the token address A and token address B. You can keep as many information as you want, it's totally up to you. Then we can keep the pool address, in which pool the user have created the liquidity. Then we have to keep the track of network, which network. Then we have to keep the track of the transaction hash. So when the user will create a successful transaction, we have to keep that information of the hash. And at the end, we have to take the time when the user have created the liquidity. And these are the information we are taking simply into our liquidity information, which we're going to simply display in the front end. So this is the struct we have. Now we can come back here and take the modifier. We'll take this only honor, because I want to restrict certain function within the contract to be allowed to call by only owner of the contract, not by anyone. So this kind of function is very important in the contract. Then we can take a require statement, and we have to check for a condition that message.sender should be equal to the admin, the one who is calling the function. Otherwise, we have to throw this error message that only admin can call this function. So this is the simple statement, like whoever is calling the function, check that he should be admin. If it's not, then we have to throw the error message and we have to stop the calling function. That's the first check. Now we have to give this slash. So if this particular condition fulfilled, then we have to simply execute to the other code, which is inside the function. So this is the first modifier we have. Now we can come back here. Let's take the constructor. In that, we're not going to do anything. We have to simply update the admin address, because he's the one who's going to deploy the contract. That's the constructor. Now we can come back here. Let's call this function AddLiquidity, and in that we have to simply take all the information about the liquidity and we have to simply update into a smart contract. So let's do that. We're going to take string memory token A, then we have to take the token B, then we have to take the token A address, then we have to take the token B address, then we have to take the pool address, and we have to take the network, then we have to take the transaction hash. So these are the information we are taking inside this function, and we'll call it external. Once we have that, we'll take this liquidity ID and we have to simply increment. Then we have to create a new ID, call this current liquidity ID to liquidity ID. And now we can simply update into our struct. So we'll take this liquidity message.sender, push to the liquidity info, and we have to simply update. So make sure to manage the order. This is the exact order we have defined in our struct, and you have to pass the data in the exact order. So we have the ID, then we have the owner message.sender, then we have the token A, then we have the token B, then we have the token A address, then we have the token B address, then we have the network pool address, then we have the network, and the last one is going to be, not last one, we have the key transaction hash, and the last one is going to be created log.timestamp. It will give us the time. Now simply close that. So that's how we can update the information into our liquidity, the struct we have created. Now we can simply come back here and close this one. So this is the only thing we have to do here into this particular function. We don't want to read out anything. So that's the only thing we have to do here. Now we can come back here. Let's build out other function which allow us to get the information from this contract. So we'll take this function get all liquidity. In that we have to simply pass the address, because here what I'm going to do is I'm going to restrict the user to access only their liquidity which they will create using our tab. So this is a very important, because we have to keep their liquidity private. You can make it global and display all the liquidity which user will create, but I want to go with You can simply display all the liquidity which user will click in your dApp, but I don't want to do that. I want to display to the user only their liquidity, not others' liquidity. So we'll take this address, we'll say public view return, and it's going to return the entire liquidity array. Now we're going to take this return liquidity. We have to simply run that, and that's the only thing we have to do. Now we can come here, let's write another function called transfer ether external payer, because sometimes we have to take money from the user. So we'll call this requirement message.value should be greater than 0. We'll say amount should be greater than 0, because if it's 0 then we have to stop that execution. Now we can simply transfer the ether to the specified address. I'll call this boolean success. We'll say admin dot call. We'll say value message dot sender. And here we have to simply check if there is a success, then we have to call transfer failed. Success can return true and false. So if it's false, then we can say transfer failed, but if it's true, then it will succeed. And that's the only thing we have to do here. I hope you guys have understood that what exactly we have to do. This is pretty simple. We have taken this contract, license identifier, liquidity, storing this state variable. This is the struct. We are taking all of this information about the liquidity. Close this one. Here we have the only admin function. We have the constructor, and this is the only function which will pass all of this data and is going to update all of this information into our smart contract. That's good. Close this one. And here we have this get all liquidity function, which allow us to get all the liquidity created by us, a single user. And here we have this transfer ether function. Close this one. So that looks good. Now we can come back here and things are looking pretty fine. So we have done the most important part. You can call it the backbone of our entire dApp. We have written all of the smart contract. So looks good. This liquidity works pretty good. Okay, close this one. Close this. Now we can come back here and we can do one thing. Like this is the contract we have written. Let's write down the script and let's deploy this particular contract which we have written. I'm going to use this particular deploy script for deploying the contract using Hardhat. But if you don't want to use Hardhat, you can use Remix ID and deploy the contract to any test network. But I would encourage you to use Hardhat because Hardhat is a powerful tool. It will allow you to test your contract very deeply, and it's a powerful tool when it's come to smart contract development. So I would always encourage you to use and learn about Hardhat because this is the most required skill you need to have when you start working in an organization. So let's write down the script for deployment. So first thing we have to import the Hardhat. I'll call it HRE because that's what they have referred in their documentation, and that's what I'm going to call it. But you can literally call anything. Now once we have that, now we have to build a function which allows us to convert the ether into way, and we're going to use it for a price, we're going to use it for a token. So let's call this one tokens. In that we're going to pass the number of token and it's going to simply convert into a way. So we'll take this return ether.utils.parsed unit. In that we have to simply pass the number of tokens and we have to convert it into a string and we have to say ether. Got it? It will simply convert that into ether. All you have to do is to pass the number. So this is the function we have. Now we can come back here and let's write the main script which allow us to deploy the contract. So we'll take this async call function main. In that we have to first deploy our token contract because our token contract, the ICO contract is dependent on the token contract. So order is very important. So I'll call this Woox token. I'll call this initial supply. So what is the supply I want for my token? I already built this internal function called token. I want to be having this much supply for my token. Pretty huge, more than a million, a billion you can call it. Now we have the token supply. I can come back here. Let's build the Woox and let's deploy the token. So we'll take this await hardhat.ether get contract, and that we have to pass the contract name. So we'll say get contract factory takes the contract name, and this is the name we have given to our contract. Okay, that's very important. Whatever name you have given to your contract, you have to pass the exact name. That's how our script can identify the contract and it can deploy. Then we have to take the entire object. In return we'll have the object and we have to simply call the deploy method. So we'll take this Woox with a small. Earlier I have taken in a capital, but here I have taken the small. You can call it whatever you want, but this is the convention I follow when I write my script for the deployment. So let's call this await Wix dot deploy. In that we have to simply pass the initial supply, and that's what we are receiving in our smart contract, in the token smart contract. So this is the first thing we have. Now I'm going to simply call this Wix dot deploy. It's going to deploy the contract, and I can simply console log out the address of the token, Wix dot address. On this particular method, dot address is available in the old version of Hardhat, not in the latest one. In the latest one we have different method. We don't have this get contract factory. It has a different method, and it has a different keyword for getting the address. It has target in the latest version. So make sure to use the exact version which I'm using. So this is how we have successfully deployed our token contract. Now we have to deploy our ICO contract. And we have to do exactly the same thing. In ICO contract, we have to pass two things. We have to pass the price, and we have to pass the address of the token contract. So we can take the price, and we have this particular function. All I have to do is to simply pass the amount I want to set for my token. So this is the fund I want to set for my token. So one token is equal to like 0.001 ether. Once I have that, now I can do the same thing which I have done over for the token contract. Pass the contract name, ICO Works. Then I can simply call the method on the object, ICO Works deploy, and in that I have to pass the token address. So I already have that Wix.address, and I have this token price. So these are the two things we are receiving in our token soil contract. Now we have to call this await and deploy, and console log out the address of this ICO token, ICO contract, sorry. So we have deployed the ICO contract as well. Now we have to deploy our liquidity contract. So call liquidity, do the exactly the same thing. Get contract factory, liquidity, we'll say liquidity, deploy, and we'll say await dot deploy, and we have to simply console log out the address. Got it? Now let's call this particular function. So we can come here, main catch, and if anything goes wrong, we have to catch that error as well. So we can say console.log, else we can simply proceed ahead, and we can say process.exit code 1, and simply do this. I hope you guys have understood what exactly we have done here. That's a very simple script we have written, and we have written tons of time this in our other project. So this is the hard hat. We have this utility function we have created right here. Convert the amount into ether, and here we have the token deployed. We are deploying and getting the address, then we are deploying the ICO, we are getting the address, and we are deploying our liquidity contract. And that's the only thing we have to do here in the deploy script. Pretty good. Now we can come back here, close this one, and now we can start working on our other section of our project. So this is the script, which looks fine. Now let's try to deploy this contract and generate the artifact and the API. So this is the exact configuration you have to do. Again, I'm telling you, this is the exact configuration you have to do. This particular endpoint, you can see I have used Acmely for this particular endpoint, RPC endpoint. This might not work in the future because I can delete that. So you have to paste your own RPC endpoint. So to get that, come back here. You can see first thing you have to get the private key of your wallet. So I'll simply log into my MetaMask, and I can go back to my, let's come here. I'm connected to the Polygon Mumbai because there we go to deploy this particular contract. So make sure to connect with the Mumbai, and if you don't have this Mumbai network in your MetaMask, so this is how you can add it. So make sure to open a new tab and go to the Polyscan, and this is the mainnet. If you want to add mainnet into your MetaMask, because when you will install MetaMask in your browser for the very first time, it will not have this particular network, so you have to add it manually. So come back to the Polyscan, simply scroll all the way down, and here you will find this button. So click on this Polygon mainnet in your MetaMask, and if you want to add the test network, so you can come back, click on this, and here we have that Mumbai test. Click and simply scroll, and here you will find the button. You can click and you can add this network as well. I have already added, that's why you can see it's throwing me this particular error. So once you're done with that, make sure that you have to select that particular network. So I'm going with Mumbai, and now you have to get the address which you want to use it. So I'm going to use this particular account number 6, or I can go with the account number 1. But what I'm going to do is I'm not going to use this account number 1 because in the last project I exposed my account private key, and some of you have drained my entire test fund, so that's why I'm not going to expose this particular one. I can go back to the account number 6 because you guys all know the private key of this account 6. So I'm going to use this particular account. I go back to the account details, and here I can get my private key. So click on this and give the password and press, and here you have the private key. Simply copy, and again I'm telling you, this one is very sensitive. If someone knows your private key, they can easily withdraw all the fund which you have in your wallet address. So this one is very sensitive. You should never expose this. This is my test network, that's why I'm showing you. So simply copy this one, and that's what you have to add here, because this is the account I'm going to use for deploying the contract. So simply paste here. Got it? This is the very first step you have to do. And come back here, and now you can simply get some free faucet, test faucet Mumbai, which you can use it for deployment. In my case, I have this much fund in my test network, test account, but you can get it if you don't have. So come back here, click on the very first link, and here you will find all the network. So you can pick any network for deployment of the contract, but I'll use Polygon Mumbai, which is very straightforward, and you don't need to have a real fund in your account to use this faucet. But if you want to go with Gorilla, Sofali, they want you to have some real fund in your account, then you can easily able to claim some free faucet. So I'll go with the Mumbai. Click, and here you have to simply paste the address of your wallet. So I will copy the address, I'll paste here, and I'm going to make a request, and it's going to give the transaction. So if we'll simply transfer the fund to my account, it will take a little bit time. You can see the transfer went through. I can simply do one thing, I can close this one, and let's open it, and here you can see I got the fund back into my wallet address. So this is the first thing you have to do. Paste your address, and you have to get your own private key and get some fund into that. RPC endpoint I will delete in future, so it will not work anymore. So you have to get your own RPC, so I can show you how you can get it. So come back here, go to ARNK RPC. So this is the website which will provide you free NPC endpoints which you can use. So come back to the endpoints. Here you will find all the network. I'm using Polygon Mumbai, so I click on this Polygon, and this is the main net, and this is the test net. So I'll click on the test net, and here I have these two options. So I'll go with Mumbai, and simply copy, and that's what you have to provide here. Paste here and save it. And here we have this RPC endpoint, then we have the wallet address, and here we are simply deploying. So I'm doing this transaction on the Mumbai test network. You can use it using the remix ID which I will show you. So let's deploy this particular one using hard hat. Now you can simply open up your terminal, and let's write this particular command: npx hard hat run network Polygon Mumbai script/deploy. So this is what we have here in this script, and that's what we are deploying. You can see this is the one which we are calling. Now simply copy and paste in your terminal and hit enter. This will take few seconds, and it will deploy your contract, and it will generate your artifact. In that you will have the API of the contract. So here I have entered, just wait. We have compiled successfully. You can see here we have the artifact. Inside the artifact we have this 3 folder like ICO, Liquidity, and Woox. In that I have the API of the contract which we need to interact with our contract. So here you can see we have deployed the 2 contract. Just wait for the 3, and here we have this. So we have successfully deployed the 3 contract. Simply select and copy. Or you can do one thing. If I open this context, in that you will see this is the old APIs which I have provided. You can simply delete this one, or you can keep it. It's totally up to you. But make sure whenever you do any changes in the contract, it will change the API as well. So you have to redeploy that contract, and you will get the latest API, and that's what you have to provide here. So I'll simply delete this one. I'll simply delete this one, old API, and delete this ICO API. I would suggest you to first build the project as it is. After that, do all the modification, because once you complete the project, you will understand everything, and then you can do modification. If you do the modification straight away, you might get confused and you might create error. So simply copy this one, and that's what we have to provide here in the context. So I'll paste here, and I'm going to comment this out. Now I'm going to simply take the API and drag and drop here. So this is the API I have. Simply drag and drop here. Let's do this for the liquidity. And we can do exactly the same thing with our token. So we got all the API. Close this one, close this one, close this one. So that's the first thing we have to do. So we have successfully deployed our contract. We got the latest API, And now we have to work on our constants. Here we have to import the ABI and export the addresses, all of things we're going to do it. And we're going to build a couple of utility function as well. So in case if you want to deploy the contract using remix ID, you can do that very easily as well. So come back to the remix ID. I believe that you guys know what it is and what it's allow you to do. So here I'm on the remix ID. I'm going to simply use this particular project, and this is the one, and I'm going to create a contract. So let's click on the new file. Let's call this deploy. You can call whatever you want. So this is what I have, and now I can simply go back to my contract which we have created, and I have to simply get that. So you have to deploy it one by one. So first you have to deploy the token, then you have to deploy the liquidity, and then you have to deploy the Wax token. This is the structure you have to follow, because this is what the structure we have followed in our hardware deployment. So I'll copy the entire token and I'll simply paste here. You can see I got it, and here I have to do the changes. I have to use injected provider because I want to use test network. If I see here, we got the chain ID for the Mumbai, and it's going to fetch the balance and the addresses. So this much font I have, and you can simply check here as well. So this is the first thing you have to do. Paste your contract here, and here you will find the contract, and this is the contract which I am deploying, and you have to provide the initial supply. So you can use the way converter, because if you look at the constructor, in that we have to simply pass the initial supply for the token, and that's what we have done. So let's come back, open a new tab, and you can use this particular website to convert it from Ether to Way. So it's called Way Converter. Click on this, and I want to have my token supply to be something like let's call this 50,000. Copy this one, and that's what you have to provide, because we have to pass the supply in Way. Paste here and click on this transaction. It's going to call the contract, and here you can see MetaMask popped up, and we are deploying the contract to the Polygon. Click on confirm, and it's going to deploy the contract. So it will take few seconds, and here the deployment successful, and you got the instead of the contract. So here we have all the function we have built in our contract, and you can straight away interact with your contract from here. This is the name. You can check the supply. You can check all of that. So simply copy the address and come back to your code, go to the constants, and all you have to do is to, instead of this address which we have got from hardhat, you can simply replace with your, but I'm going to use the hardhat one. So this is the exact thing you have to do for deploying the contract and getting the address. So that's how you can deploy. And in case of ABI, you can easily able to get the ABI as well. So if you come back here, so the moment you will deploy the contract, it's going to compile it, and it will give you this artifact. Inside this artifact, you can see we have this contract wex.json. So you can simply copy this entire ABI. This is the exact ABI you will get when you will deploy from the hardhat, or you can deploy from the remix ID. So if you scroll down here, you can see this is the ABI I have. Simply copy this one, and that's what you can simply use it here. In this way, you don't need to be dependent on hardhat. You can simply straight away interact with the remix ID and deploy and get the ABI. So this is exactly what you have to do for all the contract. I hope it gave you a better idea that what exactly you have to do if you don't want to use hardhat. But I would encourage you to use hardhat, because in that way you will understand hardhat, and it will help you a lot when you will start working the DeFi and testing the contract. So we're done with that. Now we can start working in our constants. So we have the 3 address. Now we can come back here. We'll import Ether package. Then we have to import Web3 model. Many of you have said that Web3 model is depreciated. Yes, but you have to use the exact version and it will work fine, because this particular package will allow you to write custom functionality for connecting with the wallet, and it's pretty straightforward. So we have these 2 packages. Now we can come back here. Now we have to do the internal import. So we have to import the API. So we'll take this factory API, which is already given to all of you guys. It's coming from the same directory. Then we have to import the ERC20 API, and it is also given. And now we have to use our API, which we have created for our tokens. So we'll call it Woox token API. Then we have to get the ICO API. Then we have to get the Liquidity API. We have all of this. Now we can come here and let's build the export module for the tokens ICO and liquidity. So we can call this into our context folder. So let's start with the token first. I'll take export const and let's call this Woox address. And this is the address of our token. I've simply copy and pasted here. Now we have to simply export the ABI, token ABI. So I'll say export const Woox ABI, and we have this Woox.abi. So this is for the token. Now let's do for the ICO token sale const ICO address, and let's paste that address, the address of the token sale contract. Now let's do the same thing with the ABI of the token sale. We'll say ICO.abi. Now we have to do exactly the same thing with the liquidity address, and this is the liquidity address. Now we have to export the ABI of the liquidity, and this is what we have. Now we have to get the factory contract address, because we are using this particular contract which is already deployed by Uniswap on all the network, and it has the same address no matter which network you are deploying your contract. Gorilla, Sofali, Polygon, Avalanche, it has the same address. So let's call this export const factory ABI, which we already have factory ABI, and now we can simply get the address and simply paste it. On this particular address I will provide you in the description, so you can simply copy from there and you can paste, or you can also get it from the GitHub repository in the readme file. I can provide you there, so from there you can simply copy and paste it here, because this address is very important, because some of the contract function we're going to utilize is for making the transaction. So this is the factory. Now we have to simply call this position manager address, and this address I'm also going to provide you. So these are the two addresses I'm going to provide you in the description or in the GitHub repository, so you can simply get it from there. So we are doing all this import and export from here. Now we can simply come here and let's build the fetch contract functionality. We'll call it fetch contract. It's going to take the signer, or you can call it provider. Signer will take the ABI and the address. These are three things we're going to receive it, and we're going to call this ether package, ether.contract, and in that we can pass the address, then the ABI and the signer. So it's going to fetch the information about the contract. Now we can come back here. Let's build the functionality for call web3 provider, and this is very important, because sometimes what happened that we have to call the provider and create a provider object within the function. So let's build the as a utility function which we can call in our context management. So let's call this async, and in this we're going to use the web3 package. So we'll take this try and catch to check if anything goes wrong. We have to catch that error, and we can display as a meaningful error message. So we'll take this const web3 model, and we have to use the package web3 model. Now we have to build the connection. Once we have the connection, then we have to build this web3 model dot connect. Once we have the connection, then we have to simply build the provider. We'll say provider new ether provider dot web3 provider. In that we can pass the connection. In that way we can get the provider. Once we have the provider, we can simply return the provider from the function. So we'll have the provider object, and we can catch an error if anything goes wrong. So let's console log out the entire error object. So far things are good, pretty simple. We are building this particular function which will return the provider. So when the user will connect with any network, any wallet, it's going to create the provider object which we can utilize it to connect with the contract. Now we can come back here and we can simply build the functionality. So we have built a multiple function for each one of this contract, but you can make it as a global, but I want to teach you everything from basic. So I'm going to create a separate function for each of the contract, but you can optimize it for a global object. So you can use the class construction method to generate an object. All you have to do is to pass the data and it's going to do it, but I'll go with a simpler approach so you guys can understand everything in basically. So let's call the export const. We'll call connecting contract. It's going to be an async, and that we have to receive the address. Once we have that, we'll take this try and catch. So we have to catch an error, and now we have to get the provider. So we'll use the same packages. We have to do the same thing for connection. So we'll say await web3.connect. Once we have the connection, we have to simply pass the ether provider web3 provider. In that we can pass the connection. So in that way we can use it the provider once we have the provider, or we can use the above provider function we have created. But I want to keep it synced separate, so let's go with the basically. So we have the provider. Now I can come back here. Let's create the network, because sometimes we have to get the network information, that which network user are connected with, and that's the information we have to pass into our contract, because we have a data field in our contract where we are keeping the track of the network. So take this network, We'll call this await provider.get network, and it's going to give you the entire object of the network, include the name, chain ID, and the RPC. Once we have the network, now we can come back here. Let's take a variable called signer, and we'll call it get signer. It will give me the signer object. So once I have the signer object, I can come back here. I can take the contract, and I'm going to call the internal function I have built, fetch contract, and that we have to pass the signer object and ABI and the address. So these are the three things we have to pass. Got it? Now we're going to take this. The address will come from a function when the user will pass the address into this function, and it's going to simply call all of this. Now what we have to do is, once we have the contract, now we can simply get the information. So we'll take this user address. So it's a very easy function, we can get it. I want you to write it down how to get a user address. I'm going to pause for 2 seconds and let's write it down. I hope you guys have written down the how to get a user address function. So let me write it down. So we'll say const user address, we'll say signer.get address, and this will give me the address of the user who connected with application. Once we have the user address, now I can take this balance and let's check that. So we'll take this contract dot balance, and that we can simply pass the user address. So it will give us the balance of the user in that particular contract. So once we have that one, now we can take this const name. I can take the name of the contract. I can take the symbol of the token. I can take the supply. I can take the decimal point, and I can take the address coming from contract.address. So all of this information I'm getting from this. Looks good. Now we can come here. Let's take a variable called token and store all of this information as an object, and that's what we're going to return it. So let's call that address going to be an address. Then we have to take the name. Then we have to take the symbol. Then we have to take the decimal point. Then we have to take this supply, and we have to simply convert it into ether. So we'll take this ether, utils format ether, and then we can pass this supply to a string, and we have to do exactly the same thing for the balance as well. So let me quickly pass the balance, and it will convert it. Now we have to simply return the chain ID as well, and this chain ID is available in the network. So we'll call it network.chain ID and close this one. So these are the information we are simply returning in this particular function. So all we have to do is to pass the address of the token, and it's going to return all of this information, including the balance of the user and all this information like name, supply, decimals, all of that. And now we can simply return this one, return this token. And we have to simply catch an error if anything goes wrong. So this one is a utility function. It's going to return all the valid information about the token. All we have to do is to pass the token address, and you will have all the details including a balance. So we are done with this particular function. Now we can come back here. Now we can export call const internal Woox contract. So this is the function we're going to write it down for our token contract, the internal token contract. So let's build an async. Now we have to simply build a try and catch. We have to get the web3 model, and we have to build the provider. So let me do it. Connection web3.connect. Now we have to build the provider web3 connection. So we have the provider. Now we have to get the contract. So we'll take the contract, and we have the internal function called fetch contract, and then we have to simply pass the provider and ABI, which we have imported on top, and we have to pass the address. It's going to give the contract object of this internal token we have. Now we have to simply return the entire contract, so we can simply call in our front end, in our context. And that's the internal contract, and we have to simply catch an error. Looks good. And that's exactly the same thing we have to do for other. So let's call export internal ICO Woox contract. And exactly the same thing we have to do. So let me do it that. We'll say const web3 model. Then we have to get the connection. Once we have the connection, then we have to get the provider. Once we have the provider, we have to call the contract. So we'll simply call our internal function, and we're going to pass the provider, API, and address. And at the end, we have to simply return the contract. So this one is for the ICO contract. And we have to do exactly the same thing with the liquidity contract as well. So let's call it internal add liquidity, and let's build that contract object. So let's wrap that in try and catch. We have this connection, then we have this provider. Once we have the provider, we can take the contract and call our internal function and pass down the relevant information: provider, liquidity ABI, and address. And we have to simply return the contract and catch an error if anything goes wrong. So this is the add liquidity. I hope you guys have understood. You can see there is a lot of repetitive code we have written. You can simply modify this in advanced utility model class structure, where you're going to use the class structure. All you have to do is to pass the ABI and the address, and you will get the relevant information about the contract. But I want to keep things simple. That's why I'm going with this approach, so you guys can understand that what exactly happening. Now let's write down one more function for getting the balance of the user. So it's going to be an async, and it have to be take the try and catch. We'll take a variable called web3 model. Then we have to build the connection. Then we have to get the provider. Then we have to simply call the function called signer.getSigner, and on that we can simply call the balance. We'll say signer.getBalance, and that's what we're going to simply return it. And we have to catch an error if anything goes wrong. So pretty good. So that's all we have to write here. I hope you guys have understood that what exactly we have done. All of the things we have. So we have this addresses, the modules, the ABI, the internal ABI, the token ABI and the address. And you can see if I come back here, coming there, now we have the ICO liquidity, and these are the two addresses which I have provided in the description and in the GitHub repository in the starter file, so you can get it from there as well. So this, the factory manager ABI and the position manager ABI and the factory address, and this is the internal function we have. So this is the very first function called web3 provider. This is the connecting contract for the token, ERC20 token, because different token. So we need to get the information about those token as well. Close this one. Then we have this internal Woox token. Then we have the ICO, liquidity, and we have the get balance. Looks pretty fine. So we are done with this. Now we can start working on the context. So we are done with that. Now we can come back here, and now we can start working on our context setup. So click on this, and this is what we're going to work next. Now we have to import React, use state, use effect, and that's coming from React. Then we have to import Ether and contract, that's coming from Ether. Then we have to import Web3 model. Then we have to import XCS, and we already install all of these packages if you check in our packages on file. Then we have to import the Uniswap v3 pool, because we are using the contract factory and we have this ABI. We have to get into the Uniswap v3 code artifact. Inside the artifact we have a contract. Inside the contract we have this Uniswap v3 pool, and from there we have to get the ABI of this particular contract, because we already have the address, and if we have the ABI, so we can simply pass that and we can get the contract object which we can interact. So let's get the ABI of the Uniswap v3 pool. Once we have that, now we can simply import the toaster. So if anything goes wrong, we have to display the notification, success or failure. Now we can simply do the import of the token, and that's also coming from the Uniswap SDK code. In this token, all we have to do is to pass the relevant information like token address, name, symbol, chain ID, and decimal point. Is going to create the token contract object which is going to pass into our Uniswap contract. Then we have to simply import the pool, position, nearest usable tick, and that's coming from Uniswap v3 SDK. Then we have to import the ABI, and we can call it as Uniswap v3 pool ABI, and that's coming from Uniswap v3 core artifact contract interface Uniswap v3 pool, and we have to get the ABI. Then we have to simply import the ABI as non-fungible position manager, because that's the address we have in the construct, and we have to interact with the contract as well. And that's also coming from Uniswap v3 periphery artifact contract interface non-fungible position manager ABI position manager, and we have to get the ABI. We got that ABI as well. Now we have to simply import the ERC20 ABI, and that's coming from our .ABI, means in the same directory. Now we can simply come back here and let's do the internal import, and let's import all of the function we have built in our utils, in our context constants. Let's import that. So let's say import. We have to import the ERC20 ABI, then we have to import the token ABI, then we have to import this v3 swap router address, then we have to import this connecting contract, then we have to import this factory ABI, then we have to import this factory address, then we have to import this web3 provider position manager address, internal Woox contract, then we have the ICO contract, then we have the internal AddLiquidity contract, and then we have the get balance, and that's all coming from our constants. Hope this is nothing complicated. Whatever we have built, that's all we are importing here. Now we can come back here. Let's import the parse ether, and that's coming from our utils index. So that's all the imports we have done. Now we can simply build our context. So let's call this context. We'll say react create context. That's how we can build the context. Now we can simply export and build the context provider. So we'll say context provider. In that we're going to simply pass the children. And now let's build that all variable. So we're going to take a variable called dApp name, and you can literally call anything, but I'm going to call this liquidity dApp. Now let's take a couple of state variable, which we're going to keep the track of the whether it's a token or maybe the states. That's all we're going to keep it and store it as a state variable. So let's call this const loader set loader, and by default it will be false. So when the transaction will take place, we have to manage that state and we have to display the loader. Then we have to take a const, we'll say address, and we'll take this, by default it's empty. In that we're going to store the address. Then we'll take another chain ID, by default empty, and now let's set for the token information. So we can come back here, let's call this const balance, set balance is going to be empty. Then we have to take the native token, set native token empty, and this is going to be an object. Then we have to take another one called token holders, token set token holders. It's going to be an array type because it's going to have all the addresses. Then we're going to take a token cell, set token cell, and in that we're going to store that. Then we have to take another one current holder, set current holder to be empty. Now we can come back here, let's do notification. So it's going to have two, success or failure, and we are using the toaster library. So I can say const notify error. It's going to take a callback function, so we'll pass the message and it's going to display. So we'll take this toaster.error, and in that we have to pass the message and duration. So how long we want to display the toaster. So we'll pass the message and duration is going to be, let's say, 4 seconds. The same thing we have to do for the success as well, but we have to change the method. So it's going to take toaster.success and we have to pass exactly the same thing. So this is the notification component. All we have to do is to simply call this particular function inside our component in the functions, and it will display the message. Now we can come back here, let's call this connect wallet. So now let's build this particular function. So we'll take this connect is going to be an async, and we're going to take this try and catch. First thing we have to check for a Ethereum object in the window. So if user have MetaMask already installed in their browser, so it's going to have an Ethereum object. If it's not there, then we have to throw an error message. So we'll say window.ethereum is not there, then we have to simply call our notify error and we have to simply pass the message install MetaMask, means the MetaMask is not there if there is no Ethereum object, because this MetaMask will inject the Ethereum object in the browser. Else if it's there, then we can simply take the address. So this address will come in the form of array, because in the MetaMask user can have multiple address, but we have to get the very first address which user have connected. So we'll take this await window.ethereum request, and we have to call this particular method because it has two methods. One, it will initialize the connect wallet function whenever the user will open your application, and one initialize based on the click event. So we're going to simply call this method eth request account. We're going to build this condition. We'll say if account.length exists, then we have to simply set this as an account address, and we have to take the very first account. Else we can simply display the error message, sorry, you have no account, and close this one. And we have to take this provider new ether.provider.window, and in that we can simply pass this window.ethereum. It's going to give us the provider, and we can get the chain ID from there. So we can say provider.getNetwork, and we have to simply set the chain ID to the steady variable, so network.chain ID, and we have to simply close that one. And if anything goes wrong, we can simply take a variable called error message, and we can simply call the internal function we have built called parse message. In that we can pass the entire error object. It's going to give us the response, and that response we have to simply display in our notify error component. And we can simply also console log out so to see what exactly went wrong. So this is the very first function for connect. Now we can come back here. Let's build the second function called check if wallet connected. So the function we have built, it will trigger on the click event, and this particular function we're going to build is going to check whether the user is connected or not. So we'll say if check if wallet connected. So it's going to have the similar structure. So let's call this check if wallet connected. It's going to be an async, and again we have to check for condition. We'll say account wait.ethereum request, and we have to simply call the method get account. Once we have the account, we can simply return that account, the very first account. Got it? So all we have to do is to simply call this particular function, and it's going to return the first account which user have connected. And this function we're going to utilize internally. So these are the two functions we are done. Now we can come back here. Let's build this load token, and this particular function is going to load the information about the token which the user wants to create liquidity. So we'll say await async. In that we have to simply pass the address. Remember, we have to simply pass the address of the token, and we'll take this try and catch. We'll build the token details, and we have to simply call the contract we have built. So this is the call contract connecting contract. In that we have to pass the token address, and it will return all the information about the token, and that's what exactly we have to return from this function. And we have to simply catch an error if anything goes wrong. So same thing, console log and close that one. So this is our load token function we have, because we have already abstracted our bigger function into a small utility function, and all you have to do is to simply call this function and pass the address, and it's going to give the information about that particular token. This is the load token. Now we can come back here. Let's build this GetPool address, and this one is very important function, because if you want to allow user to create liquidity, first you have to check the pool is exist on the network or not. If it exists, then we can allow the user to add liquidity on the existing pool. Again, that's the important things you have to keep in mind. We are allowing user to create liquidity on the existing pool. Let's build that particular function. We'll say const get pool address. In that we have to simply pass the token 1, token 2, and the fee. So when you pass this, it's going to return the pool address. So we'll take this try and catch. We can take this set loader to true. Then we can simply build the provider, and we already built this particular internal function called web3 provider. It's going to return the provider. Once we have the provider, now we can build this particular factory contract. We already have that one, so we'll take this new ether contract. We can pass the ABI, and we can pass the address which we have already imported. So what we are passing the factory address, ABI, and the provider, and it's going to give the entire object of the contract, factory contract, which is deployed on the network. Once we have the factory contract, now we can simply extract the data from there. So we'll call it pool address. In that we can say await factory contract, call function get pool address. All we have to do is to pass the token address 1, token address 2, and token fee, and we have to convert into a number. I remember when we are passing this particular information, the token 1 and token B, it will come in the form of object, because that's what we're going to get from the load token. It will have the entire object, and that's what we are simply getting here, token dot address, token to address and fee. So that's what we have. So this way we'll have the pool address, and once we have the pool address, we can take this pool history, and we're going to store this information in our local storage, in the user local storage, because user can search for multiple pools and create different liquidity in different pools. So we have to keep that information in the local storage so we can display to the user that these are your search, and these are the pool exist on which you have created liquidity previously or you have searched. So you can pick any one as a reference purpose. So we'll say pool history, we'll take this token 1, then we can take this token 2, and this token 1, token 2 will have the entire object. And we can take the fee, we can take the network, which is coming from token 1 dot chain ID. Whether you go with token 2 because it has the same chain ID, because we are allowing user to do the liquidity, create the liquidity in the same network, not in different network. So the chain ID would be same. And we can take the pool address and close this one. So once we have this data, we can store this in the local system. So let's build that. We can take this zero address. I've taken this zero address as a variable because sometimes what happened that the pool doesn't exist on the network. So this particular contract factory is going to return zero address. So we have to tackle that as well. Whenever we get a zero address, we don't want to store that in our local system. So here we're going to build a condition. So we'll say if pool address is equal to zero address, then we can simply display this message that sorry, there is no pool. Else we can take this let pool as a form of array. Then we can take a variable called pool list, and we'll say local storage dot get items pool history. That's the key pair I have assigned, and this is what it's going to be stored as a key pair. So first thing, I have to get an existing, like all the information from the local storage in this pool history. So we'll say if pool history means there is a list, then we can take this array and we have to justify parse local storage get pool history. We have to get that. Once we have that, we can take this pool array push, and we have to simply push our in pool history array. Once we push that, then we can simply store back to the local storage the entire data. Else we can simply store it. This time we're not going to check that whether there is a already pool stored in the local storage or not. All we have to do is we have to simply push into array and store. We can push it and then we can simply store it. Local.set item, same name, and we have to simply store it and close this one. And that's the simple thing we have done. And we can simply set loader false, and we can define this notification success. We'll say successfully completed, and we can simply close this one. I hope you guys have understood that what exactly we have done here. It's pretty straightforward, and at the end we have to simply return the pool address. Close this one, and we have to catch an error if anything goes wrong. So we'll build the error object, and we can simply pass down to our component. So we have to turn off the loader state and we have to set this to the notification. So that's our get pool address function we have. Pretty simple, not that complicated. Now let's move ahead. Now we can come here, let's build the create liquidity, and here we allow user to create liquidity. So first thing, we're going to build our internal function. So we'll say async function get pool data. So before we start creating liquidity, we have to get the information about the existing pool which we're going to use it for creating the liquidity. So we need the pool contract which we have to pass into this particular function, and in that we can take this tick spacing fee liquidity slot 0. There's a multiple set of data you will have, but we are going with this 4. Await, and I'm going to call this promise.all. In that we have to simply pass the pool contract tick spacing, because this pool contract will have all of this function. So we have to say pool contract dot fee, then we have the liquidity, then we have the slot, And this particular order is very important. You have to maintain this order. And that's what we're going to simply return. Now we can come back here and we can simply return the entire information. So we'll take this tick spacing is going to be tick spacing. Then we have this fee. Then we have this liquidity. Then we have this square price 6, and that's coming from slot 0 index. Then we have to take the tick which is in the first slot, and that's what we have to receive. And that's our internal function for getting information about the pool data, because these are the 5 data we only need to get the information and add more stuff. Now let's work on the next function called create liquidity. It's going to be nasing. In that we have to simply pass the pool, liquidity amount, and approve amount. So these are the information we're going to pass it. Now we can come back here. We'll take this try and catch if anything goes wrong, and we'll say set loader to true. Then we have to take this address, and it's coming from our check if wallet is connected, because we have to identify that who actually interacting with our function. Because when you try to get the address of the user from the global state, like from the state variable, it's going to be undefined. So it's always better that you should build an internal function which can give you the address and the information internally when the function is getting executed. In that way you will have the accurate data of the user. So let's call this particular function, and it's going to give the address of the user. Now we can come back here. Let's build a variable for provider. We already have the web3 provider. Now we can come back here. Let's build this. So provider.get. Once we have that, now we can build the token 1 object. So we already have this token method which we are getting from Uniswap v3 periphery. All we have to do is to simply pass the relevant information. So let's come back here. Let's take this token, and we have to pass the pool dot token A chain ID. Then we have to simply pass the token A address. Then we have to pass the token A decimal point. Then we have to pass the token A symbol. Then we have to pass the name. So these are the information, like all the information about the token A, token B, and fee. That's all available in this pool because it will have an object of information. So that's the very first token we have. Now we have to do the exactly for the second token. So this will call second, and we already have all of this data. So pool token B, and just get the same data we have to get, like address, decimal point, symbol, then we have the name. So we got the instant of both the token. Now we can come back here. Let's build a pool address, get the pool address which is also available in the pool object. So we'll get the very first one. Now we can come back here. We'll build the non-fungible position manager, and we have to interact with the contract. So we'll call this new ether.contract, and we have to pass the address, position manager address. Then we have to pass the ABI, non-fungible position manager ABI, and we have to pass the provider. So this will give the instant of the contract of non-fungible position manager. Once we have that, now we can come back here, take a variable called pool contract, and we'll call this new ether contract, and we have to get the contract. So we'll pass the pool address, we'll pass the ABI of Uniswap v3 pool, and we have to pass the provider. So this will give us the pool contract as well. So once we have the non-fungible position manager contract and the pool contract, now we can come back here and we can build a variable called pool data, and we already built a particular function above. We'll call it get pool data. All we have to do is to simply pass the pool contract, and it will give the information about the pool. Once we have the pool data, now we can come back here. We'll take a variable called token 1, token 2 pool. So we have to build that pool with the relevant data. So we're going to simply call this new pool, and this method is also available on Uniswap. All we have to do is to simply pass this relevant information. We have to pass the token 1, the object we have created. We have to pass the token 2, and we have to pass the pool data fee, and we have to pass the pool data square 696, and we call this string. Then we have the pool data liquidity to string, then we have the pool data tick, and this will generate the pool between these token including the fee, because we are creating liquidity on the existing pool, so it will have the same fee range. Now we can come back here, we'll build another variable called position. We'll say new position and it's gonna take an object. So first thing we have to pass is the pool, the two token pools we have created including the fee, all of this information. Then we have to pass the liquidity, which is already there. We'll say parse unit liquidity amount, it's going to be an 18, so the amount will pass for creating the liquidity. Then we'll pass the tick lower, and in that we can usable tick. In that we can pass the pool tick, pool data tick spacing. We have to minus it with the pool data tick spacing, and we have to multiply with 2. So I'm going with the equal range. I'm not going with the higher or lower, but you can go and you can do experiment with this variable. But for being on the safer side, it's better that you have to go with the equal range. That's why I'm going with this 2. But you can play with this number. Then we have to go with the nearest usable tick. We'll say pool tick, pool data spacing, and we have to simply go with the +1. In that we'll say pool data tick spacing multiply by 2, and that's the only thing we have to pass in the new position manager. So looks good. Now we can come back here, let's build a variable called approve amount, and this amount is already coming from there. We'll take this ether utils parse unit approve amount, and we have to convert it into 18 decimal points, and it's going to be an to string and it to a string. So once we'll have the approve amount, then we can build the token contract 1. So we need to get the both the contract, token 1 contract, token 2 contract, and that's pretty easy. So we'll say new ether contract, and in that we can pass the address of the first token. Then we have to pass the ABI, which we already have. Then we have to pass the provider. So this will give the first token contract. Now we have to get the second token. We have to do exactly the same thing, but before we do that, we have to simply make it call token contract 0, and we have to simply connect with the signer, so the one who is going to interact in my case when I'm doing this transaction. So I will become the signer, and that's what I'm trying to connect here. So once we connect with the signer, I can simply approve. In that approve, I have to simply pass the position manager address and approve amount. So in that way, what will happen, that I'm approving my Uniswap position manager contract to take the token from me, and they can spend on behalf of me and set as a liquidity on the chain. So that's for the very first token. Now we have to do the same thing for the second token as well. Exactly the same thing I have to do. So let's pass the address of the token B. Then I have to pass the ABI, so I can use the same ABI. I can get the provider, and now I have to simply approve. So we'll say await token contract 1. I'll call this connect signature, and on that I can simply call the approve, and let's approve the Uniswap position manager to spend our token on behalf of us. So that's what we have done. Now we can come back here. Let's take a variable, and that I'm going to take it amount 0 desired, and this one is for amount 2, and this information is coming from position mint amount. This is the method we have available, and this is for the slippage, but I'm not going to go with that. Now we can come back here. Now let's take a variable called params, and in that we have to define all the data, the final data for creating our liquidity. So let's define that. So first thing, we're going to define our token 0 means address. Then we have to define the token 2 address. Then we have to define the fee, which is available in the pool data fee. Then we have to take the tick lower price, and in that we can use this nearest usable tick. We'll go with pool data tick and pool data tick spacing, and we have to follow the same formula which we have followed on top. So I'll go with minus, and here I can simply take this pool data tick spacing multiply by 2. Then the same thing we have to do with the upper tick. All we have to do is to go with the +1. So let me do it very quickly. Tick spacing plus pool data tick spacing multiply by 2. So we are going with the lowest and to the highest 2. Once we have that, now we can come back here. We'll take the amount, and we already have this. Convert it to a string. Then we have to do the with the 1. Convert it to a string. Once we're done with that, now we can simply come back here, and we'll take the amount mint. It's going to be amount 0, and this one is the 1 for 1. Again, if you want to learn about this in detail, you can check the documentation, or I already explained multiple times, because this is a structure we have follow in most of the project with different variables. So you can simply check that. But this is what we have in the documentation, and we are just following the documentation. But I have customized it as for your easy understanding. Then we can take the recipient is going to be the address, the one who's connected. Then we can take the deadline, and I will go with this particular one, like for the 60. That looks good. So that's the entire params we have, which we're going to pass it during the function call. Now we can come back here. We'll take a variable called transaction hash. We'll take this non-fungible position manager contract, and in that we can take this connect. We have to connect with the signer. Once I connected with the signer, then I can take this mint. In that we can simply pass the entire params, and I'm going to define a gas fee for being on the safer side, because there is a lot of data we have. So we'll go with this gas side in hexi gas limit. Then I'm going to call this then, because it's going to give us the response, and we have to simply resolve that one. So we'll take this response dot hash. If the transaction is successful, it's going to return the hash. Now we have to simply build the condition. So we'll say if transaction is there, means we got a successful transaction hash, then we have to simply store that. So we'll take a variable called liquidity contract, and we already built that liquidity contract internal AddLiquidity, and we can simply store this information into the contract. So we can call this const AddLiquidity data. We have the function called liquidity contract. In that we can say connect signer, and we're going to simply call the function. So this is the function we have, AddLiquidity, and we can pass all the information. So first thing is going to be the token A name. Order is very important. Make sure this is the order we have followed in our token contract, a liquidity contract, and that's the order we are passing the data. Then we have to pass the B name, token B. Then we have to pass the address A. Then we have to pass the address B. Then we have to pass the pool address. Then we have to pass the token B chain ID, token B or A, it has the same chain ID. Then we have to pass the transaction hash. And these are the information we are passing to our liquidity contract. Once we're done with that, we have to wait for the transaction to be completed. Then we can simply set the loader to false. We can display the notification success to liquidity added successfully. And we can simply reload the window. And we can simply catch an error if anything goes wrong. So we can take a variable called error message, we'll pass the error object, and we can simply set this loader to false, and we can display this error message. And that's the entire function we have written for create liquidity. Hope you guys have understood that how things are coming together. Now we can move ahead and let's write the native token functionality, because we have our native contract. We have to get the information from our native contract, like from our token contract and from our ICO token sale contract. So we can come back here. Let's build this const fetch initial data, async. Let's take and try and catch. Let's call get user account. So we'll take this address, and we have this internal function which we're going to call it. It will give us the address. Then we have to get the user balance, and we'll say balance await get balance. This is the function we have already built. Then we can take this balance and set to our state variable in formatted data. So we'll format that in ether. Then we can take this set address, and we can simply set the account to our state variable. And this particular function will call when the user will open our application. Then we can come here, we'll call this Woox token. So now we have to get the information of our native token. So let's get the contract first. We already have the contract internal function, we have the contract object, and then we have to simply call that. So first thing, we have to get the token balance. I'll take a let variable. Then here I can build a small condition. We'll say if account exists, then we have to simply call this token balance, and we have to get the balance of the user, like Woox contract, and in that we have this particular column balance of, and then we can pass the account. So it will give that how much fund user have about our Woox token, and we can set that. Else we can simply set it to 0. So in that way we'll not have an issue if the user is not connected. Now we can come back here. Now we can take a variable called token name, and we have to get all of this information. So token name, then we have to get token symbol, then we have to get the token total supply, then we have to get the token standard. This is the additional data type we have built. Then we can take the token holders. We'll have the user ID. This will keep the number that how many token holders we have. Then we have the token owner of contract and owner. That's what we have. Now we can get the token address. This is what we have. So we have all of this data. Now what we can do is come back here. Let's take a variable called native token, and let's pass that data as an object. So this one is going to be first token address. Then we're going to take token name. Then we'll take this token symbol. Then we'll take this token owner of contract. Then we'll take this token standard. Then we'll take this token total supply, and we have to convert it into Ether. Then we have to take the token balance, which user already have. Then we have to take the token holders, and this is the idea, and we have to convert it into a number. And then we have to simply close it. So this is the entire data. We're going to set it in our state variable. So let's set that. So we'll call it this set native token, and we'll pass this native token. So this all information about our native token will be available in our state, and we can simply display in our front end. So that's the native token. Now we can come back here and let's interact with the token holders. So we'll take this variable called get token holders. We have a function already. We'll say token contract. On that we're going to call the function called get token holders. And we have to simply set, because this token holders will come in the form of array, and that's what we can set in our state variable. Now we got all the information about the token holders. Now we can come here, call getting token holders data. So now we have to get all the information about the token holders, including the ID, addresses, how many tokens they have. And we already have the function for that. So here I'm going to use this different methods. We'll say if account exists, then we can call this particular function. We'll say get token holder data. In that I can say await Woox contract. We'll say get token holder data, and in that we can simply pass the account, and it's going to return the entire information about the user who connected with our application. And we can take this, call this current token holder, and we have to simply set this data as an object. So let's set that. So we'll say token ID, and this information is already here. Get token holder data. We'll say number first, because this will come in the form of array, so we have to access in the indexing form. We have the token ID, then we have to have the form get token holder data 1, then we have to get the 2, then we have to get the total token, we have to convert it into Ether, then we have to get the, let's say what information we have to get the token holder, and these are the information we are taking and returning. So that's the only thing we have to go. Once we have the data, we can simply set this data to our state variable. We'll say set current holder to be a current holder and close this one. So that's the entire if block we have, where we are checking information of the user. Now we can come back here. Now let's interact with the token sale contract. We have done with the token contract. and all the information. Now we have to work on the token sell contract. So let's call this ICO Woox token contract, and we already have the function internal ICO contract. Once we have the contract object, we can simply call this token price. What is the price of the token? We have to get that as well. Then we have to get the token sold, how many tokens have sold so far. That's what we have to get. And we have to also get the token sell balance, that how many tokens are left in the token sell contract for sell, which we can easily able to access from here, like balance of. In that we can simply pass the address of the token sell contract. So this time we are calling the Woox token contract. We are not calling the ICO contract, because if I want to check the balance of the available token of the token sold contract, then I have to call the token contract, not the ICO token contract. And most of you get this confusion. So this is the token sell contract address which we are passing in the Woox token contract, and it will return the balance of the token sell contract. Now once we have all of this data, I can simply create a token sell object which is going to keep all this information. So I want to keep the token price to be converted into ether. Then I have to convert the token sold. Then I have to get the balance, convert into a ether. And these are the three information we want to take it from this. Now I'm going to simply set this data to our state variable. We'll call it set token sell to be token sell. Now we're going to simply console log out the entire token sell object, and let's console log out the native token and simply catch an error if anything goes wrong. So that's looks good. And that's the entire function we have for fetch initial data. So this function is very important, where we are fetching all the information about the token. And now we can simply call this particular function. We'll take this use effect and let's call this one. So we'll say fetch initial data, and it's going to be an empty array. So whenever the page will load, we have to simply call it. That looks fine. Now we can come back here. Let's build another function. So this time we'll call it buy token. So this particular function will be used by the user who wants to buy our native token. So we're going to say async, and in that we have to pass the number of token user wants to purchase. So it will say try and catch, set token true, const, we have to get the provider, which we can get it from here. Then we have to get signer. Then we have to get the contract. So we have to call the ICO contract. And we can simply console log out to see our contract object. Now we can come back here, and here we're going to build the price. So we'll take this. This is the price we have set for the token. You can get this price from the contract, but I know this is the price. So that's why I'm going with this hardcode value, because there is no function we have in our contract which will change the price. You can add that function, but I'll go with this one. And I'm going to simply multiply with the number of token user wants to purchase. So in that way, we'll get the actual amount which user want to spend for buying the number of token. We have the price. Now I can take this amount and I'm going to convert it into ether. So we'll pass this to a string ether. Now I'm going to simply build the buying await contract dot connect, and we'll call this buy token. We have this particular function. In that we can simply pass the token, and we have to pass the value, the amount, and we have to set the gas limit to be this 1 lakh, and that's our buying function. Now we can simply come back here. We'll say await.buying.wait, and we have to wait for the transaction to be completed. Now we have to reload the window once the transaction is completed. Now we can simply catch an error if anything goes wrong during the buying process. So we'll say error. We have to pass the error object, and we have to simply display in the front end. We can simply do this one, set loader to false and none notification error to be the error message, and close this one. And that's the entire buying function of token. Now we can come back here and let's work on the native token transfer, because once we deploy all the contract, the admin of the contract has to transfer the token from his account to the token sell contract in the ICO contract. Then the user can come and purchase. So let's build the function for him. It's going to be internal function. Only admin of the contract can call this particular function, not anyone. So we'll take this transfer native token, and I will go with the hardcode value because this will be done anytime. So the owner of the dApp can simply change and he can transfer. So let's take a try and catch. I can take this set loader to true. I can take this provider, which is coming from here. Once we have the provider, I can take signer. Once I have the signer, I can take this const token cell address. So this is the token cell contract address where I want to transfer the token. So this is the token cell contract address. Then I have to take the amount of token I want to transfer. So I will go with 2000. This much token I want to transfer, and I can simply build the token contract amount, convert it to a string. Once we have that, now I can build the transfer amount. So we'll take this ether utils parse token. Once we have that one, now I can come back here and let's build the contract. So we already have the contract. I can go to call this one Woox token contract. Once I have the contract token object, now I can build the transaction. So we'll take this contract, connect with signer. Then I'm going to call the function we have, transfer. In that I can pass the token address and the amount, and it's going to make the transaction. So I have to wait for the transaction to be completed. And once the transaction is completed, I have to reload the page. Now I can simply catch an error if anything goes wrong. Message.sender, we have to simply turn off the loader, and now we can simply display the notification error message. And that's the native function we have for transferring the token to token cell contract. Now build the liquidity history. So we have to get all the liquidity from the contract, which we can display in the front end. So let's build that. So we'll say get all liquidity, and we have to simply call the function. So we'll say try and catch. We'll say get user account, which we can get from the internal function. Check if wallet is connected. Now once we have that, we have to get the liquidity contract, internal AddLiquidity. Once we have that, let's say liquidity history, we can simply call this contract dot get all address, and that we can pass the account. Now we can come back here, we'll say all liquidity history dot mapping, and we have to simply map in perfect order so we can display in the front end. So we'll say liquidity array, and it will be an object type. So we'll take the ID, convert it to a number, then we'll take a network, then we have to take the owner, then we have to take the pool address, then we have to take the token A, then we have to take token B, then we have to take the token A address, and we have to take the token B address. Then we have to take the time when the transaction was created, convert into a number, and at the end we have to take the transaction hash, which is already there in the contract, and close that one. So these are the information we are simply formatting and passing as a form of array. Now we can simply return that entire array from this particular function in the front end. Now looks good. Now we can come back here. Let's return the entire liquidity array, and we have to catch if anything goes wrong. So console log out the entire array object, and that looks good. Now we can come back here and let's return the context, all the function we have built. So let's call this context provider. In that we have to pass the value, and it's going to be an object type, and we have to build and pass down all the function we have created and variables. So let's start with the function. So we'll pass this connect, then we'll pass this get pool address, then we'll pass this like load token, notify error, notify success, created liquidity, get all liquidity, transfer native token, buy token, token cell, native token, address, loader, dav name, and these are the information we are passing. Then we have to simply set the children. So close this one, set the children, and we have to close our context provider and close it down. And that's all we have to write here in the context. You can see we have written so many things, everything looks absolutely perfect. We have all of this import, then we have the Uniswap import, we have the internal import, this is the constant, this is the utility import we have, this is the context, the state variables, the token balance state variable notification, this is the connect wallet function we have, this is the check, and here we are getting the network and notification error. Close this one, and here we have the check if wallet is connected, which will return the address. Close this one. Here we have the load token. All we have to do to pass the token address and it will return the entire information. This is the get pool address. We are passing this information, getting the factory and getting all the relevant information and storing in our local environment in the local storage with this one, all these messages, and here we have the array for storing and success. So this looks good. Get pool. Then we have this get liquidity data. So this is a small function. Then we have this create, and this one is the huge one. We are getting all of this information, getting the object of the tokens, getting the non-fungible pool contract, pool data, and we have this position manager. We have the approval. This is the price range, liquidity. This is the approval amount, contract 1, contract 2 for the token, and here we have this entire params for making the liquidity, including the timing and deadline. And here we are making the transaction. Once the transaction is completed, we are simply calling our internal AddLiquidity contract and storing all of this information. That's a huge one. So this is the huge function. Now we have this fetch initial data. So we are getting some basic information about token and the ICO, and we are setting in our state variable. So this is the token, native token. Then we have this get holder. Then we have the token sale, and we are simply current holders, all the information about the token. Then we have this token sale. So this is the address of our token sale contract, and we are calling this particular token contract, not token sale contract. So that's the thing you have to keep in mind. And here we have the token sale, and looks good. So let's close this one. Now we have calling this function. Now we have this buy one. So user can simply pass the number of token he wants to purchase, and we have all of this. Buy token looks fine. Now we have this transfer native token. So this function can only call by the admin of the contract, because when the contract will launch, when he will launch the token, he has to transfer the token to the token sale contract, and that's information we are providing here. It's an internal function only called by the owner. Here we have to simply pass the address of the token sale contract, because there we have to pass the token, and we are passing 2000, and that's the simple one. Looks good. Close this one. Then we have this get all liquidity. So all the liquidity created by a single user, that's going to return from this particular contract and display in the front end. We're getting the address, passing here, and getting all this information. And here we are simply exporting all the function and the data, the state variable. And that's the only thing we have to do here. Looks pretty good. Now we can come back here. Now go to the, all of this looks good. We have done with the actually backbone of our application. Now we can come back to the app.js, and here we have done all of the things. And here we have to do the setup. So here I've done this two setup. So first thing, we have to import our context provider, which is coming from constants. So if I come back here, and you can see that here we have the provider. So this is the provider. That's what we are importing from here. And we have this toaster, which we're going to display, and whenever any message available, whether it's error or success. So let's come back here. Let's wrap this context provider. So copy, close, and close this one. And now we have to display our toaster. So we'll display this toaster. This looks fine. And that's the only setup we have to do for our context management. Let's test this out, that are we facing any error. So let's start the application. So I'll simply type npm run dev, and it will start the application on localhost 3000. And here you can see no issue we have. Whatever we have built so far, everything is working absolutely fine. So I hope you guys are on the same stage where I am right now, how things are coming. We have built all the functionality. It looks absolutely incredible. Now all we have to do is to simply work on the front end and simply connect all the function we have built. So we have this contract, liquidity, we have the token, all of the things we have built. This is the app.js. This is what we have coded, and we have built this utility. We have built this script, and we have also seen how we can use remix ID for deploying We have done too many things. Now this is what we're going to work next. All of you, welcome back to the second part of this project. This is where we left in the last video. In the last video, we have completed our entire context management, smart contract, deployment, everything we have done in the last video. In this video, we're going to work on our front-end component and we're going to connect those functionality and bring our application live. So this is the index page. This is where we left in the last video. And that's what we're going to start working on. So close this one. And before we start working on the JSX and all the component, let's import a couple of things from React and let's build out this particular index page first and its layout. So we need use state and we need use context. Then we have to do a couple of internal import. We have to import all the components we have built, and that's coming from dot slash component slash index. And we already imported all the components. So let's do one thing, come back here in the context, and here we have the index. What we're going to do is simply select all of this and simply import. We're going to use few of them, not all of them, but it's better to import all together, and later we're going to simply remove those unused component. So once we have this component, now looks fine. Now we have to import our context. So come back here, let's do import, and this is coming from context slash index. In that we have to import our context. We got this, we got the states, we got the component, and we got the context. Now we have to come back here and we have to simply import the context functionality we have built. So that's pretty easy. We can come back here, let's take a variable, and it's coming from use context, and that we have to simply pass our context. So if you come back here in the context, we have already built all of the functionality. So come back here, go to index, and here we have all of this. So simply select all of that, and that's what we're going to simply import and pass into the component. So looks fine. I get some sort of error. Okay, simply remove this from, my bad. Now it looks good. Looks good. We got our context data. Now we have to take a couple of state variable for the models. So let's call it model state, and we'll take this use state and we'll call it open add pool. So this will allow us to open our add pool component where user can search for the pool addresses. Then we have to open for the liquidity. By default, it will be false. So these are the two state variable we have, and we're going to start working on the JSX. Let's open up the terminal and let's start the application. npm run dev, and here the application is started. Click on this localhost 3000 and let me select the MetaMask, provide my password, and all the functionality is working absolutely fine. You can see our MetaMask popped up and there is no issue in that. Now we're going to start working on our index page. So let's bring this down and we have to start working on it. So first thing, we have to take a class and we'll take this CRUMINA grid, and here I'm saving it. It's opening up the MetaMask because of the phantom wallet. So what I can do, I can simply remove that wallet. So finally I have removed my phantom wallet from my browser and I'm not going to have that problem. So make sure to take a div. It will have this particular class called grid, CRUMINA cream. Inside that I'm going to take the header component. Once we have the header, let's send a couple of props. So we need the set open add pool, we need the set open liquidity, and we have to take the connect function, and we have to take the address. So these are the four props we are sending into our header component. Now we can come back here and we're going to take a div. It will have a class called main content wrapper. Inside that we're going to take our other component. So it's going to be a hero. Inside that we're going to send this transfer native token. So it's going to be an ordinary function. Once the user will transfer the token to the token cell contract, after that we're going to simply comment it. So let's send this particular function. Now that's the only thing we have to send here. Now we can come back here. Let's take another component called ICO token. Then we have to take this liquidity history. In that we need to get all the data about the liquidity. So we're going to simply call the function called get all liquidity, and that's what we're going to receive. Then we have to take the another component. This is going to be an app component. Then we have to take an analytical component. Then we have to access component. Then we have to take the ICO cell. In that we have to send the props like token cell, which will contain all the information about the token cell ICO contract. Then we have to take the native token, in that it will have all the data about the native token which is available for the ICO, including the name, supply, all of that. Then we have to send the buy function, which user can click and buy. So these are the three props we are sending. And now we have to start working on the dynamic component. So before we work dynamic component, and this component is user going to open based on the click event. So when they will click on the open pool, open add liquidity, this is the component we're going to open. So let's take a dynamic component, and that we'll say open add pool. If it's true, then we have to simply open that. So we'll take a div and let's close that one. It will have a class, and the class will be new dash center. Inside that we have to simply call the component. So this one is the add pool, and in that we have to send the prop. So let's send this set open add pool, and we have to send the load token, and we have to send this notify error and notify success. So these are the props we are sending, and the last one is going to be the get pool address. So these are the 5 data we are sending in our add pool component. If I turn it on, by default it's false. If I make it true, it's going to open. You can see there it is. It's working fine. So all the CSS we have built, it's working fine. So this is the first dynamic component. Let's do the same thing for the liquidity. So paste here, and we have to change this to open all liquidity and change the component name. So this one is going to be add liquidity, and we have to send the prop. So simply remove this one, and the prop we're going to send is this create liquidity. That's it. Then we have to get this set open liquidity, and these are the true props we are sending. So this is our 2 dynamic prop. Now we have to take the third one for the loader as well. So let's change this to loader, and here I'm going to simply call the loader component, and we're not going to have any prop in that. And at the end we're going to simply call outfooter component. That's it. You can see all the components looks absolutely fine. We have no issue in the export and import module. Everything is perfectly fine. And that's the only thing we have to do here in the index page. That's the only thing. Now we're going to start working on each component at a time. So these are looks good. Dynamic component, and we have the loader state. Now the very first component we're going to work on our header section. So simply do one thing, simply copy the props which we want to send it and get into the header component. So this is look good. Simply copy this one, get into the header component, and we have to receive this prop. So simply remove this one, remove this one, remove this, and remove this. And let's wrap this in the bracket. That looks good. So we got the prop. Now we can come back here and let's import a couple of things. So we need to import, let's import from the index, means a component, and then we have to simply import our utility function, and that's coming from utils/index. So let's import this one is going to be the header icon, and this one is the short address. So these are the 2 internal import we have. Now we can come back here. This looks fine. Now we can start working on the JSX straight away. So let's take a header. It will have a class called header. We will have a ID called site header. Inside that we'll take a div. It will have a class called container. Inside that we'll take a div. It will have a class called header content.
Guys have understood. Still have any confusion regarding the project and whatever logic we have built, try to analyze, watch one more time, try to understand that what logic we have implemented. So once you understand, it would be very easy to modify as per your requirement. So this is the standard smart contract which you will find in most of the token project which are live right now. This is the exact contract you will find. So looks fine. Now if you want to see the project, so come back to the blockchain coder. Here you will find all the resources which you need to become a blockchain developer, and you can come back to the source code section and you can check all the project we have built on our channel. We have more than 25 projects. So if you are a complete beginner, make sure to start building. The more project you will build, the better idea you will have, and you can build a strong portfolio. So for this project you can simply filter it, and here you will find this is the project we have built. Click and simply download the starter file and start building and following this tutorial. Or you can come back to this particular course which I have launched. This will teach you every single thing which you have to know about the blockchain development and all the tools which you have to know, including the smart contract development and entire programming language. You're going to build one of the biggest project ever in Web3 space. And these are the crash course we have included on most of the important technology which you have to know as a blockchain developer, which you're going to use it over and over again. So this looks fine. I want you to come and have a look. This is absolutely great. And here you will find all the materials regarding the project. So make sure to check and try to follow the tutorial and build this particular one. So that's the only thing from my end. I hope you guys have liked this project. If you still have any confusion, any doubt, let me know. And if you have any idea regarding the project, so I'll try to build that and explain you all the things which you have to keep in mind for building that kind of project. So with that, have a wonderful day. Bye-bye.